Hello, my name's Amy, and I am a recent graduate from St. Olaf. I studied English and chemistry. I am happy to welcome you to the Chrysler Pavilion and this event on resilience and management of permafrost wetlands. I also want to welcome everyone who is watching virtually, including those at the Chrysler Pavilion hubs in Stockholm and Geneva. You'll have the chance to ask questions via the chat, or for those of you in person, simply raise your hand at the end. I would now like to turn it over to Gustaf Huggelius from Stockholm University.
Thank you very much, Amy. So in this session, we'll be talking about the resilience and management of Arctic peatlands and Arctic wetlands. We'll be focusing on some of the products that have come out of a multi-year project run in the Arctic Council under the Conservation of Arctic Flora and Fauna Working Group. So my name is Gustaf Huggelius, as mentioned, and I also have my sort of co-presenters here or other editors of this report that I'm going to go into some of the details on. But first, just an overview in general. Wetlands have a lot of aspects to them that are really crucial to society. They provide us with a lot of ecosystem services. This is true for all wetlands globally, and I think it can be said to be especially true for Arctic wetlands. They moderate climate. They've been absorbing carbon for millennia. They are crucial for biodiversity, both globally and in the Arctic. They provide habitat for innumerable species. They provide access to drinking water habitats for fishing. They are crucial for food security, and you could say that they're globally important and locally important at the same time. So it's when you're working with wetlands, it's an issue that crosses a lot of scales and borders. I did want to get into a slide on. We'll be talking about peatlands and wetlands a little bit interchangeably, and this is now tying into some of the more scientific definitions of what are wetlands, what are peatlands, and there are a number of different definitions of wetlands and of peatlands, different scientific definitions, different natural definitions, different cultural definitions, a lot of different perceptions. So when you get a lot of people together trying to have discussions about the same thing, it's good that that you're actually talking about the same thing. So definitions are really important to us. Here I use one of the many definitions. This is the US one from the Cowardin system, where wetlands are saturated with water long enough to promote wetland processes. That includes poorly drained soils and hydrophytic vegetation, so plants that are basically adapted to living in wet areas. And the soils are also affected by this. They become stagnant and usually poor in oxygen, which means that the decomposition processes are slowed down and you have organic matter building up. And that brings us to the next type of wetland we're going to talk about, which are peatlands. So when you have stagnant conditions, plant remains accumulate over a long time, and you get peat accumulating in the soil. And a peatland is then a wetland that has more than 40 centimeters of peat at the surface. Then all of a sudden you have a peatland by most definitions. There are a couple of others, but this is the definition that aligns with what soil scientists would call a peatland. So that it's quite useful as it crosses several domains. Here you see a photograph of quite typical permafrost peatland in the Arctic. You see some of my colleagues are trying to dig out a profile there so that we can sample it and get some nice samples of the peat. What is actually striking with that peatland is that it's not wet. And that is because the permafrost degrading in the soil leads to a lot of ice being accumulated as well, which lifts the whole peatland or the whole wetland up. You actually get a dry surface on the wetland. Once the permafrost thaws, it's going to become wet again. But a lot of permafrost peatlands are not actually wet, which also complicates the sort of mapping and classification issues further. A lot of other Arctic wetlands are wet, of course. And here you see an example of a wetland that's formed relatively recently as a response to a very strong climatic disturbance. So you have the permafrost is thawing in this picture, and you see a wall of ice basically behind the Professor Lantui, who is standing there, and this is leading to the formation of wetlands. But of course, there are also enormous areas of pristine wetlands that are not created by climate change, and those are also the ones that we need to safeguard. I mentioned earlier that wetlands they're locally, regionally important, but they're also globally important. If you look at it, this is a map that shows northern peatland coverage north of the tropics. The redder colors are where you see more peatland. So now we're talking just peat, not the wetlands necessarily. And what we find here is that most of the northern peatlands, and indeed most of the global peatlands, are found at high latitudes in the Arctic or the subarctic. This slide shows you a couple of different lines, but if you focus on the red line and the fat black line, they show you the peatland extent and the amount of carbon that is stored in peat by latitude. So you go from 23 degrees north all the way up to the high Arctic, and then you see this really pronounced hump between 60 and 70 degrees north. And actually more than 50% of all of the global peat carbon is stored between 60 and 70 degrees north. So that is, that's an area that's also doing a huge global ecosystem service by having tied up carbon dioxide into plants, into peat for several millennia. And this and many other sort of valuable ecosystem services that wetlands provide are now under threat as the climate is warming. So that was just a general introduction, going through some terminology. And now I want to speak more on this report, the resilience and management of Arctic wetlands, which is actually, it's not just a report, it's an overarching CAF project in the conservation of Arctic flora and fauna that's been running for several years and that has several reports and outputs, and that also luckily will have a continuation into the future. First, I just want to briefly touch upon, for those of you that aren't familiar with the Arctic Council, this is an intergovernmental forum promoting cooperation in the Arctic, so it includes all of the 8 Arctic states. There are 6 permanent participants representing different indigenous groups across the Arctic, and 38 different observer organizations that are other countries, NGOs, and different types of organizations. And the Arctic Council work is subdivided into 6 working groups. AMAP is one of them, and we've seen a lot of presentations from them here. CAF, or Conservation of Arctic Flora and Fauna, is another. So this is the biodiversity working group of the Arctic Council. Even though we're talking both biodiversity and climate here today, because these issues are really interlinked. So it has board members from 8 Arctic countries and 6 indigenous organizations, and observers from non-Arctic countries and a lot of international organizations. You see some examples here. And the mandate of CAF is really to address the conservation of Arctic biodiversity and communicate its findings to the governments and residents of the Arctic. Here you see a map of the Arctic region, and the red line is the CAF boundary. So these are the areas that are considered included to the Arctic by this definition. Same as with wetlands and peatlands, there are a lot of different definitions of the Arctic as well. So sometimes different organizations take a different view to what's the Arctic. But it's 32 million square kilometers, 6% of the Earth's surface, and over 21,000 different species are found in this region. And it has a key global role, both in we already talked about climate management, but also a lot of the species that summer in the Arctic are also bird species that actually will migrate and have their home also in southern latitudes, and then they migrate back to the Arctic. So there are several global dynamics to conservation in the Arctic region. So back to the Resilience and Management of Arctic Wetlands project, RAW for short. The goal of this project is producing policy recommendations to support measures and further develop management strategies to conserve wetland biodiversity and ecosystem services that then include climate mitigation. The project has had 3 phases. It started in 2017. The first round of the RAW project ended this year. The project has been initiated and shared by Sweden, and it's been co-chaired by Iceland. And there's been support from all Arctic Council states and the permanent participants towards this project. There's been a lot of very valuable and nice reports produced by the project. You see some examples of them here. And if you're interested, I would urge you to go to this website, caf.is/wetland. That's a nice website, outlining the findings, and also where you can find links to the PDFs of the reports and other materials. So the final report of the RAW project provides 13 key findings and 20 policy recommendations that are really designed to maintain and strengthen the resilience of wetlands in the Arctic. And these key findings and recommendations were presented to the foreign minister of all 8 Arctic states at the ministerial in May of this year and adopted as part of official Arctic Council recommendations. But we also want to stress that a lot of these findings and recommendations are applicable also outside of the Arctic region. A lot of the Arctic states, our territory extends also south of the Arctic. So our hope is that while the Arctic states start to implement these, perhaps with a view to the northern regions, they can also have positive effects south of the Arctic region, of course. And there is really an opportunity for Arctic states to act as role models for sustainable use of wetlands. We have much of the global surface of wetlands is in the Arctic states, which also means that the Arctic states have a mandate and a responsibility to really take action to protect these wetlands. The policy recommendations, I'm not going to go through each and every one of them. They are divided into different sections and themes, so I'm just going to go through them. There's one theme on climate change mitigation, wetland biodiversity, and resilience. So that's the first overarching findings that really speak to the grand plans of how we can limit emissions, really try to protect wetlands. There's also some recommendations that pertain to trying to streamline national wetland governance, recognizing that in a lot of states, in the Arctic and outside of the Arctic, the present governance or lack of governance of wetlands is made really complex by a lot of different authorities tackling perhaps the same problem from different angles without having proper communication. So while reviewing the present governance of Arctic wetlands, we found that there's a lot of room for improvement and just streamlining so that everybody works together towards the same goal instead of working in parallel towards the same goal, which is what's happening now to a large extent. There are also more specific recommendations on wetland protection, conservation, and restoration. So there are different ways in which you can try to protect wetlands locally, in addition to the overall action needed to actually reduce climate or greenhouse gas emissions that actually lead to the climate change that is damaging the wetlands. There's also a lot of findings on knowledge system, meaningful engagement of indigenous communities, of local communities, and communication and outreach of wetland management, both to policymakers but also to local communities, and learning from indigenous communities that have been living and acting as part of their culture with these wetlands for decades and centuries. Then there are also findings that speak to improved products for wetland classification, mapping, and monitoring. How can wetlands better be integrated in the existing monitoring programs that we have, and how can we make better maps of wetlands that sort of work across borders and are actually useful also for international and policy actions. So then there's also a need for an overall coordination of Arctic wetland actions, research, and monitoring, both at not just at the national level but also at the international level. I'm going to pull out a few examples of paired key findings with key recommendations on how policy should try to approach these problems. One key finding is that I'm not giving you the full language. I sort of try to abbreviate it. That's why I put some dots around it. But widespread climate change impacts in Arctic wetlands are ongoing and projected to increase in this century, with catastrophic consequences for a lot of wetlands. So one of the policy recommendations is to encourage Arctic cooperation to amplify efforts to reduce fossil fuel emissions both inside and outside of the Arctic. So we're quite happy to have an official Arctic Council policy recommendation that really speaks to the need of this, because that is quite important to us. And I'm just going to give some examples of why this is really crucially important. These two figures show projections from a scientific paper that looked at scenarios of global warming and peatland permafrost thaw. You see in these red areas in the map show different areas under global warming scenarios by where we will lose all of the permafrost in the peatlands, and you see the extent going down from we're at roughly 1.1 degrees warming now, and even between 1.1 and 2 degrees, there's a very substantial loss of permafrost in wetlands. And when the permafrost thaws in peatlands, you basically have the peatlands going from being a long-term carbon sink to being a source of both CO2 and methane in different stages of the thaw. So what we find is that permafrost thaw alone, this is not counting other damage to wetlands, but permafrost thaw alone will basically push the whole carbon sink of northern peatlands from cooling the climate to actually warming the climate for several hundred years. And this is almost inevitable unless we do really rapid action to reduce climate warming. Another sort of selected pair of findings and recommendations. We also find that Arctic wetlands provide very important ecosystem services to Arctic and global communities, including climate, biodiversity, protection, water, access to fresh water, also habitat for aquatic organisms. So the policy recommendation paired here is to actively support efforts to maintain and strengthen natural ecosystem capacity, primarily through conservation and restoration measures in Arctic and boreal wetlands. So the one we had before, that was really talking about global emissions. That is a diffuse problem that affects the whole world. Now we're getting more into targeted actions on the ground, either through conservation of the pristine wetlands that we still have, or through restoration of wetlands that have been degraded. Just as an example, of following up on that, I'm going to just show some slides of a map product that came out actually this month, which is an updated map of Arctic peatlands as well as mineral wetlands. And if we look just at the Arctic region north of 60 degrees, we find that the total area of wetlands is 2.7 million square kilometers. 1.8 million of those are peatlands, and the others are areas where you have wetlands that don't have the thick peat coverage. So you see that these wetlands are distributed in the Arctic tundra, but then also these large peatland regions, for instance, in the West Siberian lowlands and in interior Canada along the Mackenzie River and the Hudson Bay lowlands. But this then becomes relevant in the context of the recommendation we just heard when we overlay our wetland map with the areas that are currently under some type of protection. These are different types of protected areas. They may be reserves, they may be national parks, etc. So you see now the wetland coverage in the protected areas. And we find that 12% of the Arctic wetlands are currently protected in some form. This doesn't mean that they are protected from all of the potential hazards that may affect the wetland, but they are protected at least in some form as it stands now. And 8% of the peatlands. Perhaps you might view this as a good start, but there's definitely a lot of unprotected area that needs to be properly managed in some way. And there are also large areas of degraded peatlands and wetlands that could benefit from restoration to sort of restore previous ecosystem services that they were providing. And the last sort of more important key finding and policy recommendation I want to lift up is that the key finding is that indigenous people's knowledge and stewardship is really important for successful management of Arctic wetlands. So this is basically recognizing that indigenous peoples are an integrated part of these ecosystems. So they are not separate, the indigenous ways of life on the Arctic land is not separate from the wetland ecosystem functioning as it is. They should really be considered as part of the ecosystems and of resilience of resilient wetlands. Excuse me. So the policy recommendation here is that wetland policy should recognize the legacy and future importance of indigenous people stewardships and the need for collaborative, integrated management of Arctic wetlands that is not a top-down action, but really also includes the indigenous communities in the planning and the stewardship of the wetlands. And here, I, as an example, I just wanted to highlight work that was done in an earlier phase of the RAW project by Victoria Bushman in a report on Arctic wetlands and the indigenous people study. So, this report has several dimensions, but one of them is looking at case studies distributed in the Arctic regions of indigenous use of different wetland areas. And I'm just pulling out one of the tables that Victoria put together for this report, and the top line shows you the percentages of where indigenous use is occurring in one of these wetlands. You see that in 83% of the cases there is some indigenous use or management happening of the wetlands, and then it's either farming, haying, herding, gathering, fishing, or hunting that is being lifted up here. So I just wanted to highlight that most of these wetlands are actively being used by indigenous peoples as part of the ecosystems. And that was my final slide. So here you have some contact information if you want to reach out to either CAF or to me. And with that, I would hand over now to the next speaker, and then after that, so next speaker is Marcus, and then we have Daly, and then we will have a short panel discussion, and then we will have questions from the audience or from people online at the very end of the session, and those questions can be to any of us. So Marcus, please.